Hello and welcome to today's episode of Astronomy Daily. I'm thrilled to bring you another packed show full of fascinating developments from across the cosmos. Today's journey through space and time will take us from the mysterious surface of Saturn's moon Titan to the fundamental forces shaping our universe. We'll explore NASA's groundbreaking Dragonfly mission, which now has a confirmed launch partner in SpaceX. We'll also dive into some intriguing new research about the early Earth that might change how we think about life's origins on our planet. We've got some mind-bending updates about dark energy that could transform our understanding of the universe's expansion, and we'll look at the largest universe simulation ever created. Plus, we'll separate fact from fiction in the world of asteroid mining and examine some important developments in GPS technology. So stick around as we explore these incredible stories from the frontiers of space science and discovery. Let's get started. In an exciting development for planetary exploration, NASA has officially selected SpaceX to launch its ambitious Dragonfly mission to Saturn's moon Titan. The contract, valued at approximately $256.6 million, will see the revolutionary mission take flight aboard a Falcon Heavy rocket from Kennedy Space Center in Florida during a launch window between July 5th and July 25th, 2028. What makes Dragonfly particularly fascinating is its innovative approach to exploring Titan. Instead of the traditional rovers or stationary landers we've seen on Mars and other worlds, Dragonfly is a rotorcraft, essentially a drone designed to fly through Titan's thick atmosphere. This unique design will allow it to travel between multiple sites across the moon's surface, sampling and analyzing different geological environments. The mission's primary objective is to investigate the potential building blocks of life on Saturn's largest moon. Titan presents a particularly intriguing target because it's the only moon in our solar system with a dense atmosphere, and its surface features liquid methane lakes and seas. Scientists believe that carbon-rich materials and liquid water may have mixed for extended periods on Titan, potentially creating conditions conducive to prebiotic chemistry. The Johns Hopkins Applied Physics Laboratory is managing the mission, bringing together an impressive team of scientists, engineers, and experts in rotorcraft and autonomous flight systems from around the globe. Their combined expertise spans missions that have explored our solar system from the Sun to Pluto and beyond, making them well-equipped to tackle this unprecedented challenge. Dragonfly represents the fourth mission in NASA's New Frontiers program, joining the ranks of other groundbreaking missions that have expanded our understanding of the solar system. The mission will search for chemical signatures that might indicate whether water-based or even hydrocarbon-based life could have once existed on this fascinating moon, making it one of our most ambitious attempts yet to understand the potential for life beyond Earth. Next on the agenda today. When we talk about asteroid mining, you've probably seen those eye-catching headlines about asteroids worth quintillions of dollars. But a fascinating new study funded by asteroid mining startup Astroforge is giving us a more grounded perspective on what these space rocks are really worth. The research breaks down asteroid metals into two categories. First, there are the platinum group metals, or PGMs, which are actually valuable enough to justify bringing back to Earth. These are the same precious metals that make catalytic converters such attractive targets for thieves, and they're crucial for modern technology. Then there are the construction metals like iron, aluminum, and magnesium, which make more sense to use in space rather than shipping back to Earth. Here's where things get interesting. Remember Psyche, that massive metallic asteroid that's often quoted as being worth more than the global economy? Well, recent research suggests that purely metallic asteroids might be more science fiction than fact. But don't write off asteroid mining just yet. The same studies show that even asteroids we thought were metal poor actually contain worthwhile amounts of valuable materials. The researchers analyzed 83 different elements from meteorite samples, which are essentially pieces of asteroids we can study up close. They found that while PGM concentrations aren't as high as initially thought, they're still much more concentrated than in Earth's ores. Particularly exciting are these microscopic structures called refractory metal nuggets, found primarily in L-type asteroids, which could contain extraordinarily high concentrations of precious metals. When it comes to space construction materials, they're about as abundant as we expected, but there's a catch. Extracting these metals requires high-energy processes to break them free from their oxidized states. It's a classic chicken and egg problem. You need significant power sources to process the materials, but building those power sources would require the very materials you're trying to extract. Despite these challenges, companies like Astroforge aren't deterred. They're planning to launch their next mission in January to study near-Earth asteroids, helping us better understand just what treasures might be waiting for us in these celestial bodies. While the trillion-dollar valuations might be overblown, the real potential of asteroid mining appears to be in its ability to support our future space infrastructure and provide rare metals that are increasingly crucial to modern technology. For our next story, we need to travel back in time. Our ancient Earth wasn't always the blue and green paradise we know today. For a long time, scientists thought the earliest period of Earth's history, known as the Hadean era, was a complete nightmare. Think endless volcanoes and meteors raining from the sky. But fascinating new research from the University of California is challenging this hellish picture of our planet's youth. The Hadean period, named after Hades, the Greek god of the underworld, lasted from Earth's formation 4.54 billion years ago until about 4 billion years ago. Yes, there were definitely molten rocks and volcanic eruptions. And yes, space rocks regularly bombarded the surface. But here's where it gets interesting. Even during this supposedly inhospitable time, liquid water was already present on Earth's surface. The research team, led by Christopher K. Jones, took a comprehensive look at how our planet evolved from its formation to the emergence of life. They examined everything from microbiology to atmospheric chemistry and from geochemistry to planetary science. What they found suggests that early Earth might have been more accommodating to life than we previously thought. One of the most significant findings is that liquid water was almost certainly present during the Hadean period. This water might have come from comets crashing into Earth or been released by those massive volcanoes we mentioned earlier. By the end of this era, the planet had cooled enough to form its first continents, with early oceans filling the spaces between them. While there's still debate about exactly what these first continents look like and how they formed, one thing is becoming clear. By the end of the Hadean period, conditions were suitable enough for life to gain a foothold. In fact, when we look at the geological records from the following Archean period, we can already see evidence of living organisms. While this research doesn't answer all our questions about how life began on Earth, it does suggest that our planet's earliest chapter wasn't quite the uninhabitable inferno we once imagined. Instead, it appears that even in Earth's tumultuous youth, the stage was already being set for the incredible story of life as we know it. Some groundbreaking news has emerged from the Dark Energy Spectroscopic Instrument Collaboration, or DESI, that's reshaping our understanding of the universe's expansion. Over 900 scientists from more than 70 institutions have been working together to solve one of the biggest mysteries in astrophysics. Why is our universe expanding at an accelerating rate? The team's latest analysis has provided strong support for Einstein's general theory of relativity, while also hinting at something incredibly intriguing about dark energy. Using observations from nearly 6 million galaxies and quasars, they've conducted the most precise test yet of how gravity behaves on cosmic scales, tracking structural growth across an astounding 11 billion years of cosmic history. One of the most exciting findings is that the clustering patterns of galaxies align perfectly with what Einstein's theory predicted. This might sound like confirmation of what we already knew, but it's actually a huge deal. You see, some scientists had suggested that maybe gravity itself behaves differently on vast cosmic scales, and that this might explain the universe's accelerating expansion. But DESI's results suggest we should look elsewhere for an explanation. That's where dark energy comes in. The analysis reveals fascinating hints that dark energy might not be the constant force we once thought it was. Instead, it appears to be dynamic, changing and evolving over time. This is a potentially revolutionary finding that could transform our understanding of the force that's pushing our universe apart. The scope of this research is truly mind-boggling. DESI can capture light from 5,000 galaxies simultaneously, and its latest analysis lets us peer up to 11 billion years into the past. What's particularly impressive is that with just 1 year of data, DESI has already made the most precise measurement ever of how cosmic structures grow in our universe, something that previously took decades to achieve. And this is just the beginning. DSI is currently in its 4th year of a 5-year survey. And by the time it's done, it will have collected data from roughly 40 million galaxies and quasars. Scientists are already analyzing the first 3 years of data, and we can expect updated measurements about dark energy and the universe's expansion in the coming months. While we're talking about scientists hard at work, in a remarkable achievement that pushes the boundaries of our computational capabilities, researchers at the Department of Energy's Argonne National Laboratory have created the largest simulation of the universe ever attempted. Using the Frontier supercomputer, currently the world's fastest, they've managed to simultaneously model both atomic matter and dark matter across universe-sized scales. This breakthrough was made possible by HACC, which stands for Hardware Hybrid Accelerated Cosmology Code. Originally developed for less powerful computers, this code has been significantly upgraded over the past 7 years to handle the immense calculations required for this kind of simulation. We're talking about a machine capable of performing more than a quintillion calculations per second. That's a billion calculations, just to put it in perspective. What makes this simulation particularly special is its unprecedented scale and complexity. Previous simulations have typically focused on either dark matter or regular matter, but not both simultaneously at this scale. This new approach allows scientists to model everything from the formation of galaxies to the large-scale structure of the universe in remarkable detail. The simulation ran on approximately 9,000 of Frontier's compute nodes, and its performance exceeded all expectations. In fact, it ran nearly 300 times faster than what was possible on previous supercomputers. This isn't just about raw computing power, though. It's about creating a tool that can help us match what we observe through our telescopes with our theoretical models of how the universe works. This advancement represents a new era in cosmological research. By simulating both types of matter together, scientists can better understand how galaxies form, how dark matter influences cosmic structure, and how the universe has evolved over billions of years. It's like having a cosmic laboratory where we can watch the universe unfold before our eyes, testing our theories against the most detailed model of the cosmos ever created. The implications of this work extend far beyond just breaking records. These simulations will help us interpret data from current and future telescope surveys, potentially leading to new discoveries about the fundamental nature of our universe. It's a powerful reminder of how far we've come in our ability to model and understand the cosmos, while simultaneously highlighting how much more there is still to learn. Next up, the Space Force has just awarded Raytheon a substantial contract extension worth $196.7 million for a critical upgrade to our GPS infrastructure. This latest investment is part of what's known as the Global Positioning System, Next Generation Operational Control System, or OCX for short. While this might sound like just another government contract, it's actually a crucial piece of technology that affects both military operations and our everyday lives. The project's total value has now reached nearly $4.5 billion since it began in 2010. And this latest extension aims to deliver new software improvements by November 2025. However, it hasn't been smooth sailing. The program is currently running about 7 years behind its original schedule, highlighting the complex challenges involved in modernizing such critical infrastructure. One of the most important aspects of this upgrade is its focus on the M-code signal, a highly secure feature that helps prevent jamming attempts during military operations. Think of it as a super secure version of the GPS signal we all use, but designed to work even in contested environments where someone might try to interfere with navigation systems. What makes this project particularly challenging is that unlike many other upgrades, which build upon existing systems, OCX requires entirely new code from the ground up. It's not just about making things work better, it's about creating a system that can stand up to modern cybersecurity threats while maintaining the precision and reliability we've come to expect from GPS. While development continues, the Space Force isn't standing still. They're currently using interim software developed by Lockheed Martin to keep the GPS network running smoothly. The complete system will eventually be installed at 17 ground control stations worldwide, forming a global network that will enhance both civilian and military GPS capabilities for years to come. And that wraps up today's fascinating journey through the latest developments in space and astronomy. We've covered quite a range of stories today, from NASA's groundbreaking Dragonfly mission to Titan, to new insights about asteroid mining, and from fresh perspectives on Earth's early history to cutting-edge discoveries about dark energy. We've also explored the largest universe simulation ever created and looked at crucial updates to our GPS infrastructure. I'm Anna, and before we go, I want to make sure you know where to find more amazing space content like this. Visit us at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed. While you're there, you can listen to all our back episodes and sign up for our free daily newsletter to stay on top of everything happening in space exploration and astronomy. Looking to connect with us on social media? You can find us on all major platforms. Just search for Astro Daily Pod on Facebook, X, Tumblr, YouTube, and TikTok. Thank you for joining me today on Astronomy Daily, where we bring the wonders of space down to Earth. And as I like to say, keep looking up. You never know what you might see.